Hi, I'm Paul Stringfellow, host of the Tech Interviews podcast. Just to let you know, this is an audio version of the show only. You're, of course, more than welcome to listen to it here on YouTube. And also to let you know, this is the last episode of the Tech Interviews podcast while we head off on our summer break. But we will be back later in the year with a whole bunch of brand new shows and, of course, more video versions of the show as well. So if you'd like to appear as a guest or have an idea for a future episode of Tech Interviews, then why not drop me an email? You can email me at podcast@techstringy.com. And to make sure you catch future episodes, then why not subscribe to the YouTube channel, or of course subscribe to the podcast in all of the normal ways. So all that leaves me to say is enjoy the summer months, stay safe, stay healthy, and of course, as always, thanks for watching and thanks for listening. Hi, I'm Paul Stringfellow and welcome to Tech Interviews. On this week's show, it's all about sticking together as we ask, where next for connectivity. So settle back and enjoy the show. Hi and welcome to this week's Tech Interviews. So this is another in our short series looking at kind of what the future is going to hold for the way that we are deploying technology throughout the enterprise. And this is not just about what going back to work after COVID-19 restrictions may mean. It's about thinking that a little bit longer term and some of the areas that you might wish to consider. And on this week's show, that I think we've absolutely picked one of those areas because we're going to take a look at networking, and how networking, what we've seen, how we've seen it evolve, some of the problems we've seen with how we've deployed networking traditionally, particularly over kind of the last 3 months or so, as we've had lots and lots of people working from new locations, and what that might mean in terms of how you think about networking in the future. So to help me to do that, because I'm by no means a networking expert, so I thought it'd be good to have one on the show. I'm joined this week by Rob Shaw. Hi, Rob. How are you doing?
Hi, great to be here. Yep, thanks for having me.
Yeah, you're more than welcome, and thanks for spending some time with us. So, well, look, before we dive into our kind of conversation around networking, why don't you, for the listeners, introduce yourself a little, Rob, and tell us who you are, what it is you do, and maybe a little bit about your background.
Yeah, sounds great. Thanks. So again, Robert Shore. I work for a company called Infinera, and what we do and what my history is about 26 or 27 years. Gosh, I feel old when I say that, but in the telecommunications industry. I actually started off as an engineer writing software, and I've held about 17 or 18 different positions on three different continents, including Europe and Africa and North America. But mostly, again, we've been in the telecommunications connectivity space. So really trying to make sure people stay connected, trying to make sure the networks have the capacity, the bandwidth necessary to enable our customers and network operators to provide the kinds of services that people are looking for. So that's been my background, and I've been in R&D, testing, customer support, field support, sales, and now I run the marketing organization for Infinera.
Well, that's a great introduction, and obviously one of the phrases that made a note of immediately as you were talking about it was the idea of making sure that we have bandwidth out for our end users, so that we can kind of operate our day-to-day business. And I suppose certainly early on, as we saw restrictions and work practices change very early on in the kind of the COVID-19 response, one of the conversations that came up an awful lot was the idea of my networking is not coping, particularly for those organizations where they were sending lots of people to work from home, different locations, and trying to get all those guys kind of hitting the data center locally. We saw that as kind of a big stretch. So, Robert, I suppose with that kind of experience in the industry, what's your view of how the networking industry, the telecoms industry, kind of sits right now, and has your view of maybe how it looks over the last 3 months changed? Has there been new problems that perhaps even with your experience you'd not seen coming?
Yeah, it's a good question. I mean, and we kind of talked about this in the lead up to this conversation, which is really I feel like all COVID really has done here is accelerated general trends that were occurring in the industry anyway. What IT departments kind of really realized in ours as well is the cloud is an extremely powerful tool for us to get our jobs done. And it enables not only better performance at a lower cost with better scalability, but it enables better localization. And we've seen a major, I would say over the last even 20 years in telecommunications, probably the most significant thing that's happened is what I call the data center revolution. And we've even got some videos on it talking about it. But it's the idea of networks not just being there to connect each other, connect people to other people, but really enabling people to connect to the cloud, to create these resource centers where massive applications can be run and huge amounts of workloads can be done. And right, that's what a data center is. Really, if you break a data center down, it's really not much more than a really, really, really big computer, right, with processors and storage devices. But what it enables you to do is scale much more rapidly. It enables you to local access information, applications, and data much more locally. And so what we've seen over the last, probably 20 years is this massive diversification of data centers and compute capabilities, to where it used to be just a few in the world. There was just a handful of them in the entire world. And now we have individual cities, like London, for example, is the city with the largest number of data centers in the world. And that has over 300 data centers just in London. So we've seen this real push to move data, move content, move applications much, much closer to the end user. And IT departments have really been able to leverage that quite effectively. It really caused a couple of really interesting things. One thing is that you look at a company like Infinera, where we have a global presence, right? So we have offices all over the world. We used to buy VPNs, right, which are private services that we buy from a traditional service provider that would help us connect our locations together. So we have location in Sunnyvale, California. We have one in Munich. We have one in Singapore, and we buy VPNs to connect all of those. We don't do that anymore, right? Because what we do is we buy a service from a cloud provider. In our case, it's Microsoft, and Microsoft has local data centers all over the world. Now all we need to do is connect to our local data center, and Microsoft provides the connectivity between their data centers. So for every place, virtually every place where we have a presence, which is over 45 different countries across the world, all of those places get to connect locally. So you get a much better experience. And this is what I mean. We were already moving in this direction of localization of data, distribution of content in data centers so that people can have a better experience. And IT organizations that help provide this connectivity have an easier way to run. Right? It's a lot easier for them to operate without having to worry about inter facility connectivity. All we have to do is connect to the data center. So with COVID pushing people to home, what it does is it increases people's reliance on the cloud. You can't really leverage local compute resources. Like if you have your own data center inside your IT organization, that's much harder to access. A lot of times those are behind firewalls or inside the VPN, and it just makes it a lot more difficult to manage by being having things in the cloud and letting people like Microsoft or others manage the security, manage the data for you. They're better at it because that's all they do, but it also localizes it. So what, yeah, what COVID has really done is it forced people to push that concept of localization, cloud-based access, much more heavily, so that people can access their data just as effectively from home as they can from the office.
And I think it's a really powerful point. I think the idea of public cloud, and certainly one of the things that we've seen in kind of certainly the initial response to how organisations dealt with COVID. I think for those companies where they had made like as you were discussing, perhaps they've taken a number of their services, given those to Microsoft as part of their 365 stack. That was a lot easier for them to make a shift once we all suddenly found all of our users working from kind of remote locations, whether that was home or normally home, and certainly weren't coming to a kind of a central office for for certainly what's in the UK here for probably the last 3 months. And that shift for people with things in the cloud was so much easier than for those without. And I suppose part of the reasoning behind why that was a much easier shift for them, certainly from a networking point of view, was something you touched on there, was the idea that, of course, Microsoft and providers like them have so much more in terms of flexibility and available bandwidth, but also kind of I guess, the smarts at the back end of that to be able to allocate that bandwidth appropriately, to be able to make those changes really quickly. So when they felt there was more bandwidth needed in a certain portion of a data center, I guess having the intelligence in their network infrastructure in a way that perhaps an enterprise maybe didn't have the skills or didn't have the financial capability to do so, to have the flexibility to redirect networking where was needed, ensure that the networking was in the right place at the right time. And I think it's that kind of the kind of approach that we've got used to with our kind of cloud compute and cloud data services, where it's about having flexibility and scale kind of on tap that we can use as we need it. That I often see, and certainly one of the things that I saw with enterprises in the initial part of kind of the COVID response phase, I guess, was where they didn't have that same kind of capability in their networking. They didn't have the same kind of flexibility and intelligence that we've started to get used to in terms of our compute. And I mean, is that something that you see that still lots of organizations are deploying networking, and I'm kind of doing air quotes here, which don't really work on a podcast, but are doing traditional networking, and if they are, what are some of the limitations that you see with that kind of approach in this kind of modern world where we need this bigger flexibility and more fluidity in the way we deliver IT?
Yeah, so it's an interesting question. So one thing that I want to credit or point out a distinction between is data center operators are really good at creating capacity between data centers and moving around workflows. So to your point, during the day, of course, in the U.S. they put processing power here to support U.S.-based businesses, and then of course they need to move those applications. Even for Infinera, even for my company, they need to move a lot of those resources applications to data centers closer to the places that are during business hours. So they're really good at providing or using connectivity, moving resources between data centers. What they really don't do is connect users to data centers. And for that, they need to partner with traditional service providers. You think Verizon, AT&T, CenturyLink, those types. That, at least in the U.S., they still need to partner with those network operators to provide the connectivities to the end users. And what we have found really is that the core part of the network, interconnecting data centers, interconnecting cities, interconnecting large hub locations, that growth has been going pretty smoothly, right? Those networks were built from the ground up to be pretty scalable. This is what we specialize in, right? At Infinera, we specialize in really high capacity transport, high capacity, long distance transport of information. So that infrastructure is pretty well suited. What everybody is really struggling with right now, and this is what's giving rise to 5G and what we call fiber deep, pushing fiber closer to the edge of the network, is the access part of the network, what connects the end user, the business, uh, cell tower, even to some extent, to the network. That part really isn't suited for what it needs to be doing. And this is what we learned from COVID, right? As everybody's at home, you've got traffic patterns that have become a lot different than they were when everybody was at work. And this gets exactly to your point, is that the core of the network is super flexible. You can really move bandwidth, change connectivity, increase scale very easily. But the edge of the network really isn't like that. It isn't as flexible as that, because it's a lot more components. The bandwidth is much, much smaller on a per endpoint basis. And to your point, when you say what needs to happen in the network, this is the big area I think we need to be focused on. Yeah, we need to continue to scale the core. So, I mean, certainly that's an issue. Bandwidth, by the way, for people who don't know, internet bandwidth grows at about 30% every year. It has for the last 10 years, and it probably will continue for the next 10 years. So you need to continue to scale the core, but the core is more set up to be scaled. It's the edge that really needs some architectural shifts to be able to scale effectively. And it's exactly what you just said. What you really need, and this is kind of our motto at Infinera, right? What we really want to do is create networking solutions to enable service providers that connect the end users to the data centers to be able to treat a communication network very similarly to the way we treat utilities like power, right? You don't think about having to order extra power when you need it. If you want to run your air conditioning higher for hot summer months, you don't have to call the power company and say, hey, can I get a little bit of extra power so I can run my air conditioning? It's just there. You use what you need and you pay for what you use, right? And that's the way we believe it's certainly at Infinera, and the way we believe the industry should be moving, right? You treat, particularly for the end user, bandwidth like power. It's just there. You have as much as you need, use it when you want, and only pay for what you need. So, in order to make that happen, there really needs to be not only architectural shifts in the network, really needs to be some technology innovations to make that happen easier. So, those are
So,
some of the biggest things I see needing. Yeah.
yeah, and I think it's a really interesting parallel as well. I started this off by saying, and anybody who knows me knows I don't purport to be, and I certainly am not a networking expert. I've been in the industry long enough to kind of have a rough idea how a network works, but I'm certainly no expert. But it's interesting parallels in the way you were talking there in the areas that I do spend most of my time in, around data, around compute. And a lot of what you're talking about there that seems to be missing in networking is the kind of thing that we're starting to get used to in the way that we deliver applications and data. It's about, we want applications and data to be where the user is. We want to, what I like to talk about is kind of a data focused approach to the way we deliver IT. We think about where do we need the data and what do we need the data to do, and not worry so much about what location is it in and what kind of hardware. Not worrying about whether it's on my favorite storage array or not, but or
Hmm.
whether it's in my data center or in the cloud, but actually, is it where it needs to be so that our end users or our customers can get the data, can get the information that they need to have. And it sounds very much like that's not kind of where the networking industry is, certainly at the end user point, but it's where you think that the industry needs to be going, and perhaps it's some of the things that you're starting to see change. So for to see networking kind of start to evolve in that way, what are some of the things? What are some of the areas that we, because you kind of talked about technology innovation and different methods of thinking. What kind of things do we need to see start to change? Both I guess at that kind of big provider level, but maybe also for somebody who's listening to this show who's designing networks for an enterprise. What kind of thinking that may they also need to be kind of adopting?
Yeah, it's a great question. So again, I'm going to constrain my answer to the areas that I have the most amount of experience with, which is connectivity. And there's a couple layers of the connectivity. Routers are considered part of the connectivity network, and it goes all the way down to the lasers themselves. So some of the big changes I think need to occur is more, see if this is a proper word here, but softwareification of the transport network, of the connectivity
Let's
network.
pretend it is. Let's have it
Yeah,
in
let's
there.
pretend it is. Well, I have a sister who's an English teacher, and she says that any word that you use that people understand is a real word. So if you understood what I meant, then let's assume it's a real word. But the idea is that a lot of these things are very rigid. Routers, in particular, is an area that I think needs to evolve. Most routers are very proprietary. Single vendor produces them. Not to cast aspersions on any solution providers of the past, but they're kind of like BlackBerry phones. They're good phones, but they just do what they do, and they're not really programmable. BlackBerry phones of old. I know there's new BlackBerry phones now. Really, we need routers that look a lot more like Android phones, which are common processor, common forwarding engine, common memory, and then you run the routing as an application on top of it, and it can host other applications as well. So we really need to beef up the software capabilities at the router layer. I think that's number one. And really, I think the idea is that, and you need to have a wider proliferation of routers through metro networks as well. But the idea, really, what I'm getting at is you need these networks, particularly in the metro and access, right? So what connects the user to the network and what connects the end part of the network into the data center. All of that needs to be two things, right? It needs to be more dynamic. And the way it gets more dynamic is that the devices providing the connectivity need to be smarter. They need to be able to understand what kind of traffic they're carrying. It's not enough just to know it's a bunch of ones and zeros. You actually need to understand a little bit about what kind of traffic you're carrying. And then they need to be dynamic enough to be able to do things based on the kind of traffic you're carrying. So the networks need to become smarter. Right now, it's historically mostly just about aggregation, that part of the network, just aggregating all this traffic and piping it all back to the center of the network and kind of letting the hubs sort it out. I don't think that's going to be effective going forward. You need to have more intelligence throughout the whole part of the network. So that's one piece. The other real piece is on the optical connectivity, right? The laser part of things. We really need to, I think, fundamentally change the way we think about lasers in this part of the network. In the core, it's all about capacity, bandwidth, reach, all of that kind of stuff. In other words, how much information can each laser transmit over what distance? How much information can you get on a fiber? That's all in the core, and we've been doing a really good job as an industry, and dare I say, us as Infinera, in pioneering along those routes to continue to push the amount of capacity the core part of the network is capable of supporting. But we really need a transition in the edge of the network to really rethink about the way we use lasers. One really interesting project that we're working on is something we call XR optics. That's not an Infinera product. That's a kind of a method of doing optical networking in the edge of the network. In particular, that's quite a bit different because one of the real deficiencies of lasers today in the edge of a network is if you think about the way traffic flows in the edge of the network, it's really a multi-point to point type of application. You've got thousands and thousands of end users, and they're really all trying to communicate with a handful of few places in the network, right, where users are authenticated in a service provider network. So the traffic patterns is point to multi-point or multi-point to point. But lasers, the current generation of laser technology we have, is point to point, right? You have one laser on one end of the fiber, you need an identical laser on the other end of the fiber. So you've got this point to point technology today that we're using to transport point to multi-point type of applications, and you end up with this technology mismatch, the technology mismatch for the application, and it ends up being overly restrictive and overly expensive. So this is what we're trying to do with XR optics, which is really change the way optics work so that they can be more dynamic, so that you can get bandwidth where and when you need it. It's not nailed up and rigid and strict like it's been in the past, but rather you use it as like kind of sub-segment currencies, or we call them subcarrier currencies, and you can move them around much more dynamically, so you can have the bandwidth follow the traffic patterns, just like you do in data centers where you have the compute power follow the need. You need to have technology and architecture such that the bandwidth can follow the need. And right now, there's really a limitation in that technology itself to enable that.
So, and again, it's an interesting. Again, I find the parallels quite interesting with kind of the conversations that we see around, again, kind of the area I'm more used to working in, that kind of thing around data and applications. Lots of things that you've talked about there. So although in that kind of second part, that's a very much kind of a low level physical and architectural change. A lot of that conversation though is still around developing things that are much more fit for purpose than what we've traditionally used. The traditional way that we've used optics and laser is not going to be fit for the purposes of enterprises around the globe in the future. That seems pretty clear from what you're saying. And I think but the other area, kind of the first part that you talked about, I think again, I think the parallels are quite interesting. We're talking about at a networking level, and for people who've listened to the show for a while, I mean, last year or maybe even the year before, I did some shows around kind of software defined networking at an enterprise, kind of a local area level. And it's interesting, Rob, that you kind of talk about there this idea of software definition at a wider area, software, more intelligence, more automation, so that our networks can make decisions based on the profile of the traffic going across them, and understanding, which I think is an important point, understanding what that traffic is trying to do, where it's trying to get to, and making changes to the network on the fly in a way that as human beings we never could. We can't keep up with that level of change across the network. We need to be able to do that at a software and intelligence level, which also opens up all kinds of other areas of flexibility. So I mean, does that sound about right? It's that kind of is my what I think you said. Have I kind of relayed that back correctly?
Yeah, no, very well actually, and really in networking, we're still at the crawl stage. So you talked about software defined networking. That's certainly a thing, and connectivity, but mostly what it is today is automating processes. That's all it's doing. The problem we have with getting to really more intelligent networks and really having things that are more automated, making better decisions about where traffic goes, and even using things like machine learning and down the road maybe artificial intelligence, but before we can even get there, we need to add the level of knowledge to the network. In other words, in the connectivity network space, connectivity networks don't know anything about the traffic. We're just, in many ways, dumb pipes. Even routers are pretty not particularly intelligent in terms of what they know about the traffic. For them, it just looks like an envelope, packet that has an address that they need to deliver it to. There's a little bit more to it than that, but fundamentally, what we need to do is add better infrastructures that have a better ability to understand things about the traffic, right? So they need to now, once you then have that capability to know more about the traffic that's being carried, then you can start introducing more capabilities, more SDN, more automation type capabilities, and machine learning capabilities that can then do more intelligent things. And one of the big things, of course, for networking, like traffic on a highway, think about it. If you had a traffic system where you can dynamically add lanes and move lanes, and you could do that based on traffic patterns, you could not only do it based on actual need, you could do it based on predictive needs. So something that people call predictive analytics, where you, based on historical behavior, you understand where capacity is likely to be needed before it's actually needed, and you can pre-prepare the network to be ready for. So there are no bottlenecks. There's no scrambling to get more bandwidth there. But we're at the stage where we really need to introduce the capability to understand to the network. And once you get that part down and ubiquitous and broadly deployed, then we can start adding automation to be able to react to things that are happening in the network. And then next step, of course, would be the predictive analytics to be able to predict things that are going to happen and pre-prepare the network to be able to support them.
Yeah, and I think that tends to be a problem across a lot of technology projects, doesn't it? In that the people are trying to build things without really understanding the starting point. They don't know enough about the things that they have to make good informed decisions about the places
Yep.
they want to get to. So it's a really interesting point. You see that kind of in the networking and connectivity space as well. I'm aware of the kind of time, and I feel like we could go down many kind of comms and networking rabbit holes and spend hours talking about this because it's a really interesting area. I think the parallels with what we see from an application data point of view are interesting, but also just the necessity that we have for communications. And it's not going to slow down. We're going to need more bandwidth pushed out to more endpoints because
Mm-hmm.
we're doing more with data. We're doing more with applications. We need more information to make even basic decisions in a way that our enterprise is going to operate. So I just wanted to kind of touch on one other thing, and I didn't want to miss out on the opportunity to chat about this because obviously you talked about technology shifts before. And obviously, one big technology shift that's just around the corner, in fact, starting to roll out now in parts of the world, is the idea of 5G networks and the kind of evolutionary effect or even maybe revolutionary effect that's going to have on the way that we can get communications to remote devices. What's kind of, how do you see that changing the way that we look at kind of communications at networking?
Yeah, I'm sorry, you said 5G. I'm not sure I've heard that term before. No, I'm just kidding. Can't walk 2 feet in telecom without hearing 5G. No, there's a couple different phases, right? One of the things people need to understand is 5G is not 4G. In other words, the transition from 4G, 3G to 4G was relatively straightforward. The transition from 4G to 5G is significantly different. It's a really different type of transition, and there's going to be multiple phases to it. Really the first phase that we're seeing right now is network operators upgrading the radios themselves, and that has some benefit. And you get radios that are capable of higher modulation. They're capable of millimeter waves, but they're really not launching millimeter wave services very broadly yet. That's really phase one. Phase two is upgrading the backhaul network, so the actual connectivity network that enables information to get from the cell tower back into the network. That's got to be beefed up, and not just increased capacity, but you really need to fundamentally change the architecture to distribute capabilities more, to improve synchronization capabilities, things like that. So they really need to augment the backhaul part of the network. You're starting to see that now. People, I think, reasonably aggressively went to roll out the 5G radios. They're now starting to upgrade the backhaul. The next stage before you really see a big impact of 5G is the deployment of more radios. And that's where you're going to really see a big impact. But you're talking about a deployment of about 5 times as many radios as they have today, because the reach for these millimeter waves is much smaller. So each radio covers a much smaller area. And that's going to take probably at least 5 years, I would contend, to start rolling out the more radios. So you're going to see a bigger impact for 5G in a handful of years, much more than you're going to see in the near term. But the real big factor for me is, why is 5G really valuable? Certainly, fiber is always the best way to connect everybody, right? That you'll never get nearly as much capacity over a radio network as you can do over a fiber. I get 40 terabits of information on a fiber, and you're not going to do that from a radio network. But why is radio really useful? 5G really useful is because it's going to help network operators reach more people with more capacity more easily. Fiber is difficult to put in the ground and difficult to put everywhere, and certainly difficult to connect to every home and every business. But if you can throw a 5G radio out there and connect, 2 or 3 thousand people with one radio with reasonably high speed traffic, that's going to be really, really useful. So I see 5G really as, I don't see it that much for mobile bandwidth, right? Frankly, I don't see people needing that much capacity on their phones. That 5G is capable of. Maybe it'll be helpful a little bit there, but that's not where really the network operators are going to generate the revenue, and it's not going to justify the business case for 5G. What's going to justify the business case is business services, residential and business services. It enables network operators that don't have a fiber footprint in an area to go in there, put a couple 5G radios out there, and poof, you can now offer business and residential services. And it's going to really, I think, proliferate much more rapidly, high capacity, end user, enterprise, resident, not enterprise so much, they usually get fiber, but small businesses and residential high-speed broadband services much faster, much more ubiquitously. And we'll have to see. I mean, in terms of what applications this is going to enable and how it's going to change and people's lives, I'm not entirely sure. I mean, you got augmented reality, virtual reality, that kind of stuff for sure. Um, People talk about connected cars and remote surgeries. I don't think connected cars need this, right? Connected cars have to be able to be managed and operate irrespective of the network. You
Mm.
can't have a car that's going to start crashing if the network goes down.
Yeah.
So they might be able to use it a little bit, but it's certainly not can't be the gatekeeper for things like connected cars, or rather autonomous vehicles. Um, but we'll see. I mean, one thing that people have definitely proven is that no matter how much bandwidth you give people, they will find a way to use that and then demand more. So,
Indeed, that's well, as many maybe a few people listen to this show know, I'm in a perfect example of that. So I'm in what I lovingly call my loftis, which is a kind of a converted loft, which is now my office. Um, and lofts are a great example of that. They are you will find enough things to fill a loft. It doesn't matter how big it is, you will always be able to expand into it. So I think that's a good example. And just, I mean, just one kind of quick thing on talking about 5G, because I realise we're kind of running out of recording time here, and I feel I could talk to you for a good hour yet. But I don't think anybody'd still be listening, certainly not to me anyway. Yeah, you talked earlier on about one of the things that you've seen during kind of the last few months, COVID related kind of things you've seen is lots of projects that were going to happen anyway have kind of been rolled out much faster. Do you think we might see that with 5G? Because obviously one of those areas you talked about was kind of business services to places where it's difficult to get good high quality bandwidth right now. Do you think that we might see a kind of an acceleration of 5G deployment driven a little bit by what we've seen over the last few months?
no. That's my short
Fair
answer.
comment.
Yeah, the reality is, right. The networks aren't. I mean, there's a lot of effort, a lot of money, a lot of expense to roll out 5G, and it hasn't slowed down, but I don't really see it accelerating that much. I think most network operators that we work with are really focused on shoring up the existing network, adding capacity and things like that. Massive new initiatives, especially initiatives that require a lot of feet on the ground and physical touch points. Um, that's certainly not going to accelerate during COVID, right? It's hard to get people to the field. Certainly hard to install things at end locations as people restrict who can come in and out of the buildings. So yeah, the short answer is no. I don't think it's going to accelerate something like 5G that has a lot of physical touch points associated with it and a significant amount of expense. It hasn't slowed it down, but I don't think it's going to accelerate it. So again, I kind of reiterate or stated what I think the 5G timeframes are. Radios are going out now, backhaul starting very shortly here, and the expansion of the radio network probably won't even start in any kind of significant fashion until 2022. I don't even see a lot of radio expansion projects in 2021 personally. I think 2021 is going to be mostly about upgrading the backhaul network.
So, well, I mean, yeah, I think it's a good, honest answer, and I won't rush out and buy all my new 5G equipment just yet. Then,
Yeah, probably not. Well,
look,
but
Rob,
again, I'm sorry, real quick, just to be clear, 5G will be out there, right? So I mean, all these service providers saying, "Oh, we have 5G." They do have 5G to some extent. It's just they've upgraded their existing radio towers to 5G. You're not going to see a massive boost in performance. You'll see about a 10% or so improvement in performance with 5G equipment today, because all they've done is increase the radio. They're not using millimeter waves, but they are using higher modulation rates. So you will get better performance. So don't not buy 5G stuff. Just don't expect a 10 times improvement in performance when you buy it until maybe 2023 or 2024. There we
I'm
go.
not going to get the full 5G dream, is what you're telling me right now.
Exactly. Yeah. A few years yet.
Well, I mean, just before we do wrap up, Rob, and I appreciate we're kind of running short on time here now, but so obviously you've mentioned your company Infinera a couple of times, so if people are listening to this and want to understand a little bit more about what you guys do, so maybe you can tell us actually a little bit more about what you guys do, and also for listeners who are interested in finding out more about maybe where you can help, how do people go about and find out more about what you guys do and where they can get help?
Yeah, great. Thank you. I appreciate that. So, what do we do at Infinera? We provide connectivity solutions, right? We help connect users to the network and help build out the networks themselves. One of our core areas of specialties is optical networking innovation. So, building the lasers that transmit information from one place to the next. And we do all that in-house. It's one of the things that makes us special. So we have a lot of innovation in driving new types of technologies in optical networking, enabling people to transmit more information over greater distances at a lower cost, lower power, all that kind of stuff. Historically, a lot of our innovation has been focused on core networks, really, right? Helping connect data centers, helping connect major cities together, things like that. Increasingly, though, we've started turning our innovation to the metro, and we talked about that project XR Optics, which is a industry initiative that we're trying to lead here. That's going to help change the landscape of the way end users are connecting using optics. We also do sell solutions across the stack, though, so we go up and all the way from the lasers as well as routers. I talked about those Android-style routers. That's another big initiative for us, too, trying to softwareize, there's another new word, routers, making them more Android-like as opposed to the way they are now, which is more traditional BlackBerry-like. So that's really what we do. Obviously, all of this comes with an overlay of some software automation, professional services. Building networks is not something you order on the internet. There's things that have to be planned, built, and we stay with our customers throughout that entire process. So, in terms of where people can find out more information, obviously the best place to go is our website, which I have to promote because my team builds the website and manages the website. So hopefully you like it. We've done a lot to try to make it engaging and easily understandable, but that's just www.infinera.com. Infinera, Infinera, stands for Infinite Era. Before my time, I didn't pick the name, but it's still kind of a memorable name. So that's a really good place to go to learn more about us. And definitely, if you want to learn even more, you can feel free to visit our LinkedIn page. Again, just go to LinkedIn and look up Infinera. That's also the best way to contact us. There's a contact us certainly all over our webpage, but also on LinkedIn if you want to find out more information. But we print a lot of really good articles. If I do say so myself, we write a lot of really interesting blogs. It's not just a bunch of information about Infinera products like a lot of people do. We have a lot of networking insights and personal narratives that we write in there, our thoughts, our opinions as to what's going on in the industry as well. So feel free to check that out either on our blog page or we put them all on LinkedIn as well.
Well, I would definitely recommend that blog page. Obviously, when Kenny contacted me about coming on the show, it was one of the areas I went to. I had a look at the very nice website. Yes, Rob. So you can pass it on to the team. Had a look at some of the blogs and some of the kind of the think pieces on there, which were interesting. And certainly, I would recommend that people go and take a look at them. And I'll make sure links to all of those things go in the show notes, including kind of your LinkedIn page, etc. So, well, Rob, look, really appreciate that. I think it's been a fascinating conversation. I've learned a lot. I've learned some new words as well, which is always nice. But look, Rob, thanks for coming on the show. Appreciate your time, and look forward to having you on again as a guest in the future.
Yeah, anytime. Really good conversation. Thanks for having me.
I hope you enjoyed that. For show notes, pop over to the subtly rebranded techstringy.com. We'll also find all of our previous Tech Interviews podcasts. Now that's the last in this current series of shows. We're going to be taking a few weeks off over the summer, but we will be back later in the year with a whole brand new series of Tech Interviews podcasts. Now, if you'd like to appear as a guest on those future shows or have an idea for a show, then why not drop me an email at podcast@techstringy.com. And to make sure you catch those shows on their return, then why not subscribe? You can find us in all good homes of podcasts, as well as, of course, now on YouTube on TechStringy TV. So until next time, I hope you all enjoy the summer months. Stay safe, stay healthy, and of course, as always, thanks for listening.